So today's webinar is going to be focused on getting the best out of forecasting software. Just a few housekeeping bits. So we will be sending a recording of this webinar to everyone after the presentation is done, along with the slides. If you do have any questions, please use the Q&A functionality, and that should send some questions across to ourselves and the two presenters that we have today. If you're having any technical difficulties or you want any help, you can use the chat functionality and someone from the team will get back to you straight away. Apart from that, please do enjoy this webinar, and I'm going to pass things straight over to our two hosts today. Thank you.
Thank you. Hello, everyone. I'm Robert Fildes, and I've got my colleague Nikos, I can't pronounce it with any Greek skill, Kourentzes. We're representing the Centre for Marketing Analytics and Forecasting at Lancaster in the Department of Management Science, which I'm sure many of you know. The centre, just very briefly, we'll say some words about the centre because it's relevant to why we decided to offer this webinar. We've, for 20 years or more, been involved with companies and organisations in general, government, in various projects, which are occasionally consultancy, sometimes courses, but more particularly they're master's student summer projects. In fact, the department goes back into the 60s, working with companies on their projects. And these projects have typically, and of course increasingly, offered and required software of one form or another. And so the development of software has become very much a part of what we do, both in terms of new techniques, which Nikos has been very much involved with, but also just advising companies and organizations on what sort of software, and quite often tuning the software. Forecasting software, I don't know when I came to this conclusion, is very fundamental to the whole development of forecasting, not just in practice, but in research as well. So you get some original methodological ideas. Back in the 70s, William Jenkins, who was at Lancaster, and Jeff Harrison, who was head of ICI Management Services. ARIMA models were developed by Jenkins with his colleague George Box. Jeff Harrison, with Colin Stevens, published an influential article in the journal of the Operational Research Society, or I think it might have even been ORQ, Operations Research Quarterly, back then. Jeff's ideas were in Bayesian forecasting. The ideas that you're probably familiar with are due to Jenkins and his ARIMA model building. What really mattered to the success of those two techniques, or the relative success, was that software in the NAG library was developed to support the ARIMA models. So you got the original ideas, but the software became fundamental to the adoption into organizations of the particular technique. So it's not that Bayesian forecasting was worse or certainly not better than ARIMA modeling. It's just that the software was available for people to adopt. These days, of course, things have changed, and typically software is available through sometimes very large systems, and we'll talk somewhat about those large systems in organizations. We've got econometrics software, but without that adoption, you do not get better forecasting. So a key issue is the delivery of software and the design of software to support the different uses. So I've, on the left-hand side of the screen, suggested some of the uses. Of course, there's research uses, analysts who can be extremely expert, can write the software themselves, and we'll be talking about the increasing use and growth of open source software. But probably the biggest group of people who use forecasting software are demand planners. They may be called all sorts of different things, but basically they're people in organizations who've got a major function in using commercially supplied software. Sometimes, however, they'll have devised their own software in Excel. So a variety of attempts to match the jobs that people do with the software. Now, the software suppliers are also a crucial group of people. I don't know whether there are any software suppliers in the audience. There probably are, but from my perspective as a researcher, they're a disparate group of people. There are software suppliers who really commit to understanding what the best ideas are, adopting the new technologies into their software. There are others where the forecasting component is just a very minor part of it. And finally, of course, there are researchers who will be devising their own software packages. Within applications areas, it's worthwhile commenting that there are software-specific packages, which we won't be talking about particularly, but we're happy to respond to any questions on that. So again, another big applications area in forecasting is for call center planning. So there is software which produces call center forecasts, and call in forecasting is quite a specialist area with complex seasonal aspects to it, for example. In electricity demand and pricing, again, there are specialist software, and there are specialist types of methods which are applicable in both these sorts of areas. So software and the development of good software is critical to the adoption of different and new methods in organization. So with that as a background, our agenda today is the first aspect. What do you want from forecasting software? And I've already mentioned the need to match the software to the job. Easier said than done, and some forecasting companies, I wouldn't say many forecasting companies, have worked hard at trying to do that. Obviously, I exempt those which are more research orientated. Then there's the question of choosing the right software. What are the components? There's the must-have aspects to it, like to have. And of course, the supplier themselves. And finally, and perhaps a rather neglected area, is getting the best from the chosen software. Because most commercial software comes in wrapping, in the sense that it's not tailored to the organization. There'll be a consulting charge for that software, whether it's software designed by consultants or whether it's buying in the latest SAP software. So one way or another, you've got to say, okay, here's the software, we've got it, how can we get the best? And what I mean by best is the accuracy. So if you look at the overall process of organizational forecasting, that's one of the fairly complicated slide, but I've circled the areas that we're going to be concentrating on. We're going to assume away the rather important aspect of whether there's sufficient data for the statistical modeling. We're not really going to be talking about new product forecasting. Again, we'll respond if you've got questions on that. But once you've got a given data set or a possible potential data set, you want to understand that data, and then you've got to choose a class of model from a wide variety these days of possible models before you produce the initial forecasts. Those initial forecasts in most organizational settings, and this includes all retailers, or large retailers certainly, manufacturers, but also includes weather forecasters, the Bank of England. They essentially will discuss the forecast with the organizational stakeholders, and that potentially leads to a revised statistical forecast because there's been some judgmental intervention which has affected that final forecast. So that's the process we're going to focus more on. Now, if you take, and this attempts to apply to pretty well everybody who's producing forecasts, that's a sort of stylized view of these activities I've just sketched out. First, there's a definition of defining the database. It's, I mean, it seems curious, but we go into organizations, which is very much part of what we continue to do in the center. And the first question, what data do you have available to help you? It can be overly limited, of course, for all sorts of reasons. We talk about living in the age of big data, but it doesn't necessarily mean that that data is readily available for use. Once you know a bit about the data, that starts to tell you about the range of forecasting methods that you need to consider. And as I've mentioned, it's a wide range, a widening range even, with the development of artificial intelligence, machine learning methods. So you've got a rapidly developing range of sometimes really very abstract, complex methods. Okay, but once you've got the software operational from a range of methods, you need to select which of those methods you're going to use and then estimate the model. Well, actually, that's mostly pretty easy. It's easy because that's done by the software. Some software developers have decided how that's to be done. Incidentally, and this is possibly a topic to be picked up on, a recent article was looking at machine learning methods and demonstrated rather convincingly that of the 5 or so programs that actually they were evaluating, only 2 of them were producing reasonable results, which is something to be pretty scared about, actually. So you need, one way or another, to be confident about the software and that it's actually doing what it claims to be doing. And Nikos, you might have some views about that, particularly in the area of machine learning.
Well, it's a bit of a wild west there, because you have, from one hand, a lot of researchers, from the other hand, a lot of libraries, and many of these have not been sort of validated against each other or verified if they give the results they're supposed to. But what is surely very true about many of these implementations and libraries is that they don't necessarily follow the textbook definition of what these techniques should do. And that's for a good reason, typically, because there is a large number of hyperparameters or hard-coded settings that are not so straightforward to, in a sense, check if they're done in a way that fits the problem that we're applying the particular software. A good example of that is the very initial implementation of decision trees that had so many hard-coded parameters in it that made it work very well. But if people tried then to replicate what the academic research was supposed to be doing, couldn't get similar results. So there is a question, how many of the machine learning implementations out there fall a bit under the same kind of questions?
Funnily enough, this basic issue takes us back to exponential smoothing and Bob Brown's work in the 1950s and early 60s, when hard-coded into the very primitive computer programs was a smoothing parameter of 0.2 or 0.3. This was the answer to selecting and estimating the forecasting model. And as we've discovered a few years later, really, it took us a while, that's just not appropriate. Anyway, here we are, we've estimated the model, we actually believe the results. Then what happens? Well, there's other information, typically other information about what's likely to happen. I mean, I was talking with a retailer the other day, and I thought that retailing, at least, most of the forecasting was automatic. You'd automatically produce, once you've chosen your model, you'd get your forecasts, and they would be part of the forecasting decision support system, whether it was in terms of scheduling call center people or electricity production or so on. That's not true. For the retailer, it's a hot summer. We're going to have to do something about it. We're currently in Sweden, in Stockholm, and their summer was They had about 30 days of temperatures around about 30 degrees. So the retailer has to change it. I've called it market intelligence, but it's actually in this context, weather intelligence. You know your models are not going to work effectively under certain circumstances. So you're going to take market intelligence. Sometimes you get forecasts from other bits of the company or the organization, functional forecasts, I call them. It can be an advice. So we're going to combine these various sources, some user reconciliation, perhaps including logistics, supply shortages, and so on. So one way or another, we're going to take a range of models, choose a model, estimate the model. That's sort of the easy bit with some of the provisos I've mentioned, and then combine with judgment. That is what, for almost all forecasting, in practice, what it's about. So the key elements then are selection, and we'll pick up on some elements of that in a few moments. Tuning for organizational forecasting, because it can be extremely expensive to buy this software, leaving aside issues of training staff. For operational forecasting for a retailer, the software will typically cost more than £1 million. And then the final stage is incorporating the market intelligence. So we're going to pick up on all those key elements. Now let's think about the different types of software. As part of the centre's activity by a series of accidents, we got asked to, by Informs, the US equivalent of the OR Society, to produce a survey of forecasting software. They've been doing this for many years, actually. I think the person who was responsible had declined and got past it for whatever reasons. So we wanted to revisit the survey from scratch. We found over 100 forecasting software products, all sorts of varieties, some very specialist, some generalist, and we're going to pick up on the types in a few moments. Persuading these software suppliers to respond was pretty exhausting, but we got over 20 respondents, and we're in the process of updating, again, attempting to persuade companies to update, because there's an online version of it. The survey, as it said, has been going about 20 years. So the class of software that we identified, general purpose statistical. It used to be true that SPSS, for example, didn't have any forecasting components to it. That's no longer true. Certainly Starter, for example, has really quite strong time series analysis in it. You've got some specialist forecasting packages, much more limited statistical methods geared very much to producing forecasts. Econometric packages, really for the expert, often used by the researchers. Many, many packages there. Perhaps the most important set of packages are forecasting support systems, which link to ERP, Enterprise Resource Planning Systems. They link into the organization. SAP is the most well-known, most well-established. I think it's the biggest software company in the world, in fact. Forecasting is just a small part of those systems, but it's a crucial part. And finally, of course, there are rather more general mathematical and statistical languages, and they have forecasting programs, routines written into them, of which MATLAB or R or Python, and again, are part of this. And finally, there's Excel. I'm going to pass over to Excel, to Nikos, but with a question really, effectively, on the next slide. So what's wrong with Excel?
Well, I think the main issue that we find with Excel is essentially the flexibility, how many different things it can do. And on one hand, this is a fantastic feature because you can ask many questions on that software and you can try to get reasonable solutions and with many reasonable different types of inputs of data. But that's precisely the problem, because then you end up having ad hoc solutions, customized solutions, solutions that may have programming errors. There are often, and this is very true, of course, for older versions of Excel, that there was no forecasting built in it. Now, in the newer versions, there is some forecasting built in it, but here is the relevant question. Is that forecasting actually following the latest research? Or eventually we have here a tool that people think now, okay, we can do forecasting, but actually falls into traps that older software used to have, or still has in some cases. So in some sense, Excel is the basic software that almost all companies use, but and because, for a good reason, for its flexibility and its ease of use, but that's exactly also its failing in many ways. This flexibility gives the space for a lot of mistakes in Excel. Now we can go a bit more technical in that discussion and say, okay, how easy is to load big chunks of data, many different variables, how is to do statistical analysis, or for example, is it fast enough in running computations that require lots of data? But in some sense, these are technicalities, because more often than not, this is a secondary problem to having actually a mistake in the implementation that is quite common in Excel. I think both Robert and I, in our experience with practice, whenever we get our hands on implementations in Excel that companies have, I cannot remember of a case where we couldn't spot at least one mistake. Now, sometimes these mistakes are relatively innocuous and don't really make a big, let's say, impact on the forecast, but more often than not, they are not that small, and they can have a significant impact.
I mean, the real problems, aren't there, with the process? One case study we had was where the analysts, and there are quite a lot of forecasters, and this was supporting engineering forecasting, were shifting data from one Excel spreadsheet or one worksheet to another, and that copying was potentially really, because it was many rows and many columns, just was unvalidated, and it just wasn't confirmed that there was doing with any accuracy. And another issue we came across was spreadsheets which are just so massive, they just took ages to update and therefore ages to check. So major issues there.
I think one further point, returning back to the introduction or less of Robert's, is that it's one thing to get a number out of Excel, it's another thing to get it through a process. So if you have a very flexible software, that requires you also to design a forecasting process that will follow the right steps. For example, how do we validate that the forecasting model we're using is the best given the data we have to forecast? How do we compare these forecasting models? How do we optimize the parameters? Indeed, Excel can allow you to do some of that stuff, but does it guide you actually through the process in a way that is meaningful, or it will help you get the right result? And that's also very relevant to the third point in this slide, which is open source versus proprietary software. So open source, we will come back to that towards the end of the presentation, is often great in getting some of the numbers right, and often it's state of the art, but it's a forecasting algorithm or a method out there. It's not part of a bigger ecosystem. And the proprietary software often has a specific opinion on how things should be done. But again, there's a question, is that process backed up by evidence that is effective in getting you the right forecast? So if we proceed a bit further on that and look a bit at the current issues. Of course, one issue is, I already alluded to that, how do we make sure that the implementation we have is the right implementation? How do we benchmark the forecast that we have on our hands? Now, if we think, how do we produce this forecast? Well, we need some data, and this may sound as pretty straightforward, but all of you who have some understanding of practical problems, you will appreciate that getting the actual historical demand, or whatever is we're trying to forecast anyways, in the system is not that trivial. Either the data quality is not there, the history is not there, data are overwritten, we don't have access to the historical data because they're in some warehouse that belongs to different function in the organization, and it's not trivial to get it. So different organizations will have different challenges, but what often, let's say, researchers or software engineers think as trivial, we get the data in place, it's actually not. And often there you find different software having different hard-coded limitations, I would call, which is essentially, oh, you have to work with 3 years of data. Why 3 years? Because 3 years. There is no real statistical reasoning behind it. Now, then you have the aspect of, and as already Robert mentioned, it's not just getting statistical forecast in place. You also have to introduce in that forecast any additional information, any soft information that you have from the context, from the market you're operating in. So any adjustments we're doing on the forecast based on the expertise of the users. And there is a question here, how it should be done. Is there an interface for that? Is it just some number we plug in and we don't care about how this is done? Or do we actually need to record what was the statistical forecast, what was the judgmental forecast, so we can go back to it and then say, okay, this is actually what was the change that we caused in the forecast, and this is the impact we have in accuracy. So we can, in some sense, benchmark the different steps in the forecasting process. It's not just having a feeling of how accurate is the final forecast. If you think about it, it's we have some methods there, and if anybody of you follows the academic research, you will see that there are always papers who argue this is the best method for this problem, or this is the best method overall. And in some sense, academics here are a bit guilty, because in order to get our papers published, we need to say we are doing great. But this isn't an ideal world. Once we start having in all the complications of reality, like, for example, very noisy data, missing data, corrupt data, how does these things work? And once we have these problems and we start manually adjusting, either by cleaning up history, as it's often called, or correcting data, or applying any kind of heuristics to make the data set more reasonable for the forecasting method, what do we actually have then? Do we have, do we gain in performance? Do we lose out and we haven't really realized it? And of course, when we implement on top of it the judgment, what's happening there? So, thinking about how this should be done back to the forecasting process, there is a question of testing these forecasts and having what we often call in the literature as a rolling origin, that is, run essentially a competition between different techniques, but not only on a single forecast, but running them several times and collecting evidence that for the particular problem, for the particular product or time series we need to forecast, that's a reasonable forecasting approach. And I use the word approach because it's not just a statistical model. We have issues about the data being messy, and messy is the kind of word here. So is it outliers? Is it data that is going to zero? Is it data that is just missing? How do we deal with these things? And what's the sensitivity of the solution we have on our hands based on these things? And the other aspect, of course, is just because we have some data on our hand, are we using the right level of the data? Are we looking at the aggregation level that is relevant? Or should we look at the more disaggregate or aggregate level? Just because, for example, Excel has some data entries, that may not be actually the best way to solve the problem at hand. Another question, of course, is what is the problem at hand? Robert was a bit going not so much in the details on that, but at least there is the aspect of the forecast horizon. How long do we need to forecast ahead? One sure finding from the literature that is always there is that a single technique, a single approach is not relevant for all different objectives and planning horizons. Short-term forecasting, long-term forecasting require different solutions. And if we are then stuck with a particular software that doesn't make this evaluation easy and transparent, then we may often result into just using one approach to forecasting out of convenience. And convenience is not necessarily because we are being lazy here, it's because it's just very, very difficult to get the evaluation properly.
Can I pick up on that issue? Because it's two things that are a bit shocking. First, the organization own KPIs don't focus on what the key forecast horizons are. And second, the measures that are produced by standard software really require, at best, you have to calculate the errors for the forecast horizons manually. There are just one or two packages which will do it automatically. They do exist, but actually it's crucial to establish aggregation level, horizon level, and ensure the software, and you sometimes would have to write your own to supplement it, the software produces your KPIs that actually matter.
That's right, and this goes a bit into the monitoring, because the forecasting process doesn't stop at here's the number, now let's give it forward to the next function in the organization and forget about it. We do have actually to record how well we're doing. in terms of the statistical software, in terms of the statistical forecast, in terms of the adjustments and so on. And a question we often get asked here is, okay, we're talking about benchmarking. Give us a feeling of, are we accurate or not? Well, from one hand, as academics, we always don't want to put our hands on fire and say yes or no in a definite. We always say it depends. But more crucially, if we think about all the differences that each different company has in terms of processes, in terms of available data, in terms of implementations of algorithms and so on, it's actually very difficult to benchmark across companies, even in the same sector. I won't even go in discussing between sectors, but surely it's possible to do it within the organization.
Well, it's even difficult under those circumstances. We were looking at a manufacturer a few years ago with 4 major clients, and accuracy varied very dependent on who the client was. Was it the forecaster who was associated with each client, or was it the client's behavior? On balance, it was the client's behavior. But if you used the accuracy to evaluate, to promote, or to fire the forecaster, you would be very unfair. So real dangers. So really the only way, and this is something that the Centre has done for organizations, the only way to benchmark your activity is to go through a sample of time series of your data and so on to calculate the relevant accuracy measures.
Yes, so I think that the point that here we need to make is that if there are all these different criteria in getting the right forecast in place, then surely, given the variety of the problems you face, you really have a case of horses for courses, where through this benchmarking process, one can identify the approach that's relevant. Now, this of course brings a question back to how softwares are producing forecasts. Do they give you the flexibility to do all that stuff? And also what is happening in practice. So what we have here is we have some recent studies that were done that are trying just on a bird's eye view, give you a feeling of how these forecasts are actually produced. And you will actually find that across these studies, the numbers don't vary that much. And there is a good chunk on average that is done based on judgment alone. Statistical methods exclusively is about the same, but then you get a mixed percentage of a combination of statistics and judgment. Now, one thing we have to keep here in mind, of course, that judgment is really never out of the process, because even if we go fully statistical, someone set up this statistical approach. There is the judgment of this analyst, of this modeler in there in the first place. However, that doesn't really go into the operational side of forecasting, where at each cycle, we have then to implement additional judgment. And if we look at the numbers here and we add up wherever judgment appears there, it is the majority of the cases. So again, a question based on what the softwares give you. Is there a functionality, is there a facility there that allows this implementation of judgment and the evaluation of judgment to be seamless? Do we aid the experts to superimpose their knowledge, or do we make it difficult for them? And even if you think about it, it's not just about in our sort of business world. In almost every different situation, judgment is critical. Yet it's one of the aspects that most software, even the research level softwares, actually do not really bother about. So if we think about eventually how do we get a forecast? From one hand, you would have standard techniques, extrapolative forecasting, like exponential smoothing, ARIMA, averages, or any other methods that you may have available. And then you have questions of selecting the right flavor of the model, parameters, how to make sure that your choice is, from one hand, the most accurate at hand, or other cases, the most robust, so it stays more or less stable across different cycles of the forecasting process. From the other side, you could go with the causal modeling thinking, where you're saying there is some additional information in other drivers, in other variables, such as, let's say, promotions, discounts, or even, for instance, locations and so on, the weather information, or bank holidays, other explanatories anyways. And then it's a matter of how do we specify these causal models? How do we verify these causal models? And obviously, one could think about both elements being relevant. You have the dynamics of the time series from one hand, and you have all the mechanistic approach of causal modeling coming into place as well. Something that seems to be, for instance, one direction that promotional models for retailing seem to be taking. And of course, on top of it, as we said already, it's the question of superimposing the expert information in the most reliable way. I'm using the word reliable here in terminology that we want to make sure that from one hand, we can evaluate what is the added value we have from this expert information, and from the other hand, to sort of aid the process. So just thinking about these steps, and here we have a case that we have looked at as a center in the past, where what is the question here? We have a company that is using some version of SAP APO with some standard settings in there, using the automatic process. So our approach to benchmark it was, first of all, to check against the naive. If you just copy the previous historical value as a forecast, can you beat that? So a very, very fundamental benchmarking that, to be fair, a lot of software don't show it as an out-of-the-box feature, or at least they don't force the user or the modeler to check it. And it's a big failing, because if you can just copy the last value and get a better quality forecast, that surely says something about the current settings. Then another approach in terms of benchmarking is that naturally there are different software out in the market. So how about running the same data through a different software? What would be the accuracy here? So for example, as the slide suggests here, if we used for the same problem Forecast Pro, you would get better accuracy. So smaller percentage errors. And in this case, the percentage errors were smaller than the naive. So at least there was some added value there.
Yes, reassuring.
And what we try then to do is, given the constraints of the software at hand, could we actually come up with a better setup that could actually get us to where we wanted? And that would be the red bar here, where essentially by doing the right analysis, we could pick the correct models and then the correct parameters and get good quality forecasts. Now, what has been quite interesting about this project is that all this analysis had to be done outside of the interface of the provided software, because in the particular case, SAP APO could not actually give us the transparency from one hand or the options to do this kind of benchmarking. So we had to do it externally. So ideally, we would like this to be a feature of the software to help the analyst. If it takes eventually a team of academics to do that, that's surely not the usability we're looking for. If on the other hand, I can give a slightly brighter note on that, Forecast Pro, for example, provides a lot of this functionality. The question then is, do we have the process as it actually has been demonstrated to add value, or is it just the opinion of a software? And here I'm not taking a particular critique or let's say, a bonus on Forecast Pro. But it's not just getting the statistics right. If we think about then the further step of the process, it's about judgment. And I don't think there is a single paper or empirical evidence we have that judgment does not add some value, but surely it's inconsistent. It's not like every single adjustment is adding value. For instance, what we did here is, once we had a setup of statistical forecast that we could rely on, we then superimposed the expertise of humans that had this market understanding. So you have here two bars. You have the final adjusted forecast with the light blue bar, and then you have the statistical forecast. And you can see here that this green area is essentially how much value you had added by doing these adjustments. And you can notice here that, for instance, in case of small adjustments, there was no improvement. So by recording this feature, by looking back at the past forecasts, at the past errors, one could say, well, look here, there is a clear outcome. Do not bother about doing this small adjustment. This is just tweaking. Now, I'm not going to go if it's a general finding or not, and Robert's research has been primarily on this over the last year, so he has a lot to say about this, but surely you can do it on your own data. Surely you can do it on your own statistical forecast as a starting point. So here you could see, for example, if we do this analysis, you could see that experts were really adding value in this range of adjustments. And then the question was, how can we support them to do this even better, if possible, and stop them wasting their time in doing small adjustments all the time? So one could argue, well, this is a matter of setting up the process correctly. We would argue this is also part of what the software should provide you as part of the interface. And this is, to be fair, active research. It's not like that academia has said, these are the 5 steps that you need to follow that gives you the best advantage. Now, if we just think about this case, we have from one hand then, starting from an initial setup, improving the forecasting models in terms of the statistics, and that gets us up to point. Then we have to think about, okay, can this be implemented within the existing software? So therefore, you have to do this analysis under the constraints of what are the available techniques with their peculiarities, implementations, and so on. How to then help the judgment. First of all, check that the value is there, and eventually why we're doing all that. Because at the end of the day, we want to have the savings, for instance, we had in this particular project. Okay, so once you have done all this selection properly, you have the judgment working in place. The whole forecasting process essentially is now seamless in the software. You hope that you have essentially the improved service to your customers. Now, and I don't want to spend too much time on this slide. There are many different factors that will affect your software, and the follow-up slides go more into these dimensions details, but one box here that is very important is the organizational culture. No matter how good is the statistical software that you have on your hands, it's also a matter of the culture that you have in the organization. So, do I have access to the right data? Do I get the soft information that is not part of a database on time? Or do I actually believe it? How is the communication running within the company? What are the targets am I going for? Is it always improve your forecast by 10%? Well, that's a very nice target to have, but is it feasible? If I could improve my forecast by 10% always in the stock market, for example, surely I wouldn't be here right now. So there are questions about the culture and how this will affect eventually all the software aspects. But I don't want to spend more time on this slide, but more going to the different dimensions we have. So thinking about, for instance, software. Okay, we want to have different statistical techniques or machine learning techniques. Surely these have some hardware requirements. Now, if you have to forecast, let's say, 100 or 1,000 items, nowadays, that's not a problem. If you have to forecast 1 million items, that can actually become a problem. And you can think about, from one hand, now a compromise between complexity of methods against the cost of hardware. It may be in principle okay for an academic saying, okay, you have a farm of computers and you run it. How expensive is to run that farm of computers? What do you gain in accuracy? Does it make sense at the end of the day? Then you have questions about data handling. Any organization will have different sources of information at different functions, different levels of the organization. How do we integrate all that? And once we have somewhere this data set, this database, does it connect seamlessly with your software? For example, open source, very nice idea, often helps with the cost, but does it connect nice with your existing data warehouse? Open question there. The forecasting features. We did mention quite a few things about the benchmarking, so I won't go too much again into that, but surely this has desirable features there. Depending on in the case you're trying to solve the forecast, do we need, for instance, multiple seasonalities? Are we having to forecast intraday data, or are we dealing with monthly, weekly data? In one case, multiple seasonalities are a necessity, it's not an option. In the other case, it might be an interesting feature in case we want to go to more detailed forecasting in the future. Surely an aspect that is not always there, and that's a big problem, is prediction intervals. This gives you an idea of how uncertain or certain is your forecast, and surely informs decisions further on, or should inform. Should is the key word here. But it's one thing to say, oh, this is how people should use the forecast. If the software doesn't provide this basic information, clearly users will have no view of it.
It's worth pointing out again the need to link to the decisions. In a lot of manufacturing organizations, the forecasts are used as part of ordering, and it's true of retail as well, ordering and into inventory. And whether that measure, which is based on the forecast errors, the real forecast errors for the appropriate time horizon, are implemented successfully is a very open question and rather doubtful.
That's right. One other aspect that we haven't touched upon that is one of my personal favorites is hierarchical forecasting. So, for example, thinking about different aggregations levels or disaggregate forecast down to the stock keeping unit level and so on. Does the software provide that, or does it look at data as individual series somewhere in an abstract way? Eventually, things are in an organization, so they have to connect somehow. Continuing on the software dimensions, again, we have to think about the tools. From one hand, in terms of explanatory tools. So, can I, for instance, check if my series have trend or seasonality? It's a fairly straightforward and basic question, But it's not so easy for many software, especially if the software not dedicated forecasting software, but just provides some forecasting functionality. Back to Excel, for instance, yes, it has some forecasting functionality. Does it help you do the right exploration so you do the right choices? It's an open question. And we can then argue about more advanced things like decomposition, like the X13 ARIMA. Now, arguably, this is not necessarily the most relevant for every single case, but really it's one of the features that, is it something that potentially can be useful? Going back to the must-haves and would like to have. In terms of forecasting methods, now, one thing that is surely true is that most software, or let's say different packages and solutions, eventually have a preferred approach of solving a problem. It's not so common that you find a package that can offer you essentially the full broad spectrum of techniques. And I'm not talking about an exhaustive list of techniques, but at least having extrapolative and regression techniques at the same time. Something quite basic. Or for instance, having machine learning and statistical techniques at the same time. Because this is really, really crucial for making sure that you can compare this between them and pick the right one for your problem. So going back to the open source and getting very close actually to the end of our presentation, we can go for some questions. Open source has become quite fashionable lately, and personally I'm a big proponent of that, and some of you will spot at the end of the presentation, we'll provide some packages that the sender has authored over the years. Now, is it a zero-cost solution? Well, it's a good question, because yes, you may get an algorithm out of the box and it works quite all right. And the quite all right typically will be state-of-the-art, because often it's supported by the academics who have developed this in the first place. There are questions about how professional is the implementation, how scalable is the implementation. But surely that is just a forecasting method somewhere abstract. It's not connected in an interface, more often than not at least, is not connected to the database. There is this cost of integration. Now, at times, this cost of integration is much lower than getting a proprietary software. But I will always put here the question of what is the quality of this implementation, of this integration, and eventually the scalability. Surely there is an interesting point here of being state-of-the-art. And one thing that many people should keep in mind is that software houses have now realized this interesting point, that if I can provide within an existing software a way to load up open source code, then I can sort of get the best of both worlds. Back to the question of cost there. And if I think about the alternatives on that, then you could think about forecast as a service. It's not a new thing, though many people are now starting to open up new startups or even existing companies, like we have here Amazon as an example, who say, give us our data or upload them on the cloud or some sort of interface, and we will provide you forecasts for this data. Well, in principle, that sounds quite all right, but outsourcing is something that in the managerial literature, at least an experience, is either a very bad or a very good thing, depending on the camp you are. But surely there is a question about transparency. When I have this as a capability in my organization, I know exactly what's going on, or at least I can have the potential of knowing exactly what's going on with my forecasting. In some sense, know what is already in place and seeing what additional expertise I need to superimpose, what soft information can be done there, can be added there. So there are these questions about transparency and trust as well. If I buy forecasts and I get the final forecast back in my organization, or maybe this forecast, there is some consensus with the expertise in the company, how do I actually trust it if I see in some months erring in particular ways? And I have to be fair here that this is the case also for software. And at the end of the day, again, goes down to the cost. How is the running cost of having this as a service, as an in-house developed software, perhaps with help from open source, or a particular proprietary software? So that goes essentially full circle to our initial slide. What are the must-haves, what we would like, and eventually knowing really what we need to forecast, having a clear objective, having clear specification of what we need. It all eventually comes down to how much support we need or how much knowledge we have in-house, and what is the price we're willing to pay, either in terms of software, in terms of service, or in terms of building the expertise within our organization. We're almost there.
Yeah, I'll just take a point from the last slide, the issue of support. You can't take it as read and some of you will perhaps know this to your own cost, that the software supplier actually knows anything at all about the algorithms or the tuning of the algorithms in the packages. So that, for me, would be a core thing. Now, as part of the centre's activities with organisations and our own ingenuity with new methods, I shouldn't say mine, Nikos's and colleagues, there are a whole set listed there of packages written in R which help you. For example, let's just take the bottom one, perhaps particularly interesting, as Google Trends. There is one thought in the forecasting world about whether Google Trends can help you substantially improve your forecasting. The research evidence that we've published suggests not, but in doing this analysis, it does lead to some improvements in some situations. We've obviously had to develop some software to do exactly that. And as you can see, we've publicized our book on the principles of business forecasting. So to close down, what are our takeaways? A key issue is matching organizational processes. If you go into an organization, you can ask them, what is the process by which forecasts are produced? We've sketched out some archetypal processes with the judgment and the choices that people in the organization make about methods as a crucial component. The research suggests that often the software does not match the processes, and that mismatch leads to people squeezing out and fighting the forecasting method. So, for example, in a pharmaceutical company, you've got possibly an S-shaped curve, but exponential smoothing will never give you an S-shaped curve. So what they had to do was change the database to get the forecast they wanted in the first place. Software quality is variable. You have to benchmark those methods, either yourself or get a consultant or whatever. They need to be validated against established software, if you're buying new, if you will. And finally, and we've repeated this, managerial intervention is a key feature. But it's a feature from selecting the method, selecting the parameters, tuning the parameters, and of course, the final forecast.
We have still some time for questions, and I noticed that some of you have already written down some questions, which we'll try to read through, but let us just go through them. I don't know if also people want to open up the discussion. One of the comments we have here in the chat is that about Excel, which goes back to the idea of expertise, because and that's actually very true. It's a good point to highlight that there will be always people in the organization who will be able to develop good solutions in Excel, but eventually it's a question of, will these people eventually stay in the organization? Is the knowledge in the team or in the person who may move on or eventually not and may maintain the solution? And that's another problem, because you don't want essentially all this knowledge to be lost.
There's a question there about SAP. Why were the errors so large? I don't think it has much to do with SAP particularly, because Forecast Pro did better, but it was still a 40% MAPE, wasn't it? That's so right. Effectively, because it was difficult data, and that's why comparative benchmarks across organizations is really not possible. You need to use an established software to benchmark the forecast, and for those particular, was it pharmaceuticals? I think
it was pharmaceuticals.
Just very high errors, basically. Tough problem.
I don't know if we're missing any other question here, but feel free to either write on the chat or if you have microphone to join in the discussion.
Yeah, as Nico just said, so if you would like to ask your question out loud, please use the raise hand functionality that should be on your screen. So it looks like a little tiny hand. So if you press that, I'll be able to unmute you and you can ask your question, or alternatively, you can just type it in the Q&A panel. Just gonna look around, see if we've got any questions. We've got a question there that's just coming from Tracy England. If you guys want to pick that up.
I need to go down or up.
Hasn't arrived to us yet.
If you go down, it should be in the Q&A. I can just read it out.
Yes,
so
please.
We have Tracy asking, do you have similar experiences when working with public sector bodies?
The problems essentially are identical. Obviously, the types of data that you're using are different. So one big deal is promotions for many manufacturers and retailers. That's not so typical. But issues of events, seasonality, these types of issues. And crucially, we've been talking often about forecasting many data series. There will be many different classes of client, for example, that you need to forecast. Call center forecasting is common across the public services as well as the private. So all the issues we've identified, I think, carry over. The importance of the individual ones, you'd have to look at the application.
There is another question here about hierarchical forecasting, and indeed we didn't of that one because it's a big discussion on its own. But the question is, what are the pros and cons of this approach? Well, hierarchical forecasting essentially goes with the idea that within an organization you will have some sort of a natural hierarchy. For example, products will aggregate up to market segments or geographies or product categories and so on, up until to eventually the total for the whole organization. Now, the two advantages that you can see from hierarchical forecasting is essentially that you expect typically some gains in accuracy, but that's not the primary benefit they have. The benefit that is actually the big deal with hierarchical forecasting is that it makes sure that the forecasts are what we call coherent or reconciled. That is essentially that the disaggregate and the aggregate forecast point to the same direction. I often see in many discussions in practitioner forums this idea about the one number forecast. Hierarchical forecasting goes towards this approach, getting this one number forecast. Now, the downside of this is that this is really where open source shines, because the solutions you have for hierarchical forecasting in many of the software packages is just not up to scratch. And this is not actually a snipe at the software companies. It is that this is very new and current research. I actually had a discussion about that not so long ago, and the key papers are 2017, 2018. So I kind of appreciate if it's not still not production.
Nikos was correcting one of my slides and pointing out that my questions had been answered. I'm not so sure. But anyway, yes, and to link this question with the public sector question, if you take, for example, the Ministry of Justice or the DWP, perhaps, you've got different types of clients. And effectively, you're trying to work out workloads and things like that. And different clients have different needs and different requirements and different time demands. And so you can see the hierarchy adding up.
Great. Thank you so much, both. I don't think we have any other questions, and we seem to be a little bit over time now. But I just want to thank both of our presenters and also to our audience for joining us on this webinar. So unless there are any further questions,
well, you can always email us anyway with questions. We'll try to get back to you.
Absolutely. So all those contact details are on the slide that you should be able to see right now. If you do want to ask any further questions or start any extra debate, please feel free to either get in touch with us on our social media at the OR Society, So that's on Twitter, Facebook, and LinkedIn. Additionally, we will also be sending a recording of this webinar along with the slides.
Great. Well, thank you all.
Thank you all for your time and hope it was useful.
Perfect. Thank you all.
Bye.
Bye-bye.